How was silicon used in the 50s transistor invention? Imagine a tiny piece of material that could control electrical signals better than anything before it. That's what silicon became in the 1950s. During this time, scientists started replacing germanium with silicon in transistor making. Germanium was used first because it was easier to work with and could handle higher frequencies. But it had problems. Germanium transistors were sensitive to temperature changes and leaked more current when turned off. This made them less reliable for everyday electronics. Silicon, on the other hand, could work over a wider temperature range, from about -55 degrees Celsius to 125 degrees Celsius. It also had much lower leakage currents, which meant it used less power and was more stable. The first silicon transistor was created in January 1954 by Morris Tannenbaum at Bell Laboratories. He used a process called the Grown junction method, which involved carefully controlling how impurities were added to silicon crystals as they grew. Soon after, engineers at Texas Instruments, including Gordon Teal and Willis Adcock, developed and started selling silicon transistors made from high-purity silicon supplied by DuPont. This was a big step forward. They doped the pure silicon with tiny amounts of other elements to create regions with extra electrons, called N-type, or with holes, called P-type. These regions formed the transistor's structure, allowing it to amplify signals or switch currents on and off. The use of silicon also led to new innovations. In 1955, researchers discovered that growing a thin layer of silicon dioxide on the surface of silicon could protect and insulate the transistor. This was a key development that led to the creation of the planar transistor. The planar design made it possible to put many transistors onto a single silicon chip, which became the foundation of integrated circuits. Back then, switching to silicon was seen as a sign of progress and modernity. It promised more dependable electronics that could power new consumer products like portable radios and hearing aids. It also helped pave the way for the computers that would soon change the world. So, in the 1950s, silicon was used because it offered better temperature tolerance and lower leakage currents than germanium. The techniques to grow and dope high-purity silicon crystals made it possible to produce reliable transistors on a large scale. This shift marked a major turning point in the history of electronics, setting the stage for the entire digital age.